Welcome to my talk on non-application layer malware communication. One of the first things that malware analysts do when trying to understand a new sample is to see what kind of communications it makes. This can be DNS requests or HTTP post messages, but what if it's non-standard? What if it uses a custom protocol on top of TCP that you've never seen before? Or it uses ICMP, which is typically not blocked or monitored as closely as standard protocols. That's exactly what we're going to look into in this talk. Before we dive into the technical details, I want to frame this talk in terms of three main ideas. The first one is that malware is not required to use an application layer protocol. It is likely you will still see them using an application layer protocol for convenience or in order to blend in, but it is not necessary. The second idea, it's not just a theoretical capability. Malware samples have been using non-application layer communications for many years at this point. Lastly, it is very easy to build proof of concepts for non-application layer communications, so these capabilities will not only be limited to sophisticated adversaries. Now that we've got these main ideas in mind, let's hop in. So what are non-application layer protocols? First, let's remind ourselves of application layer protocols. If we remember back to our OSI model of networking, the application layer is layer 7, or the closest layer to the user and probably the most frequently used and recognized. You can see some of the application layer protocols on the slide, but many others exist: SSH, TFTP, DNS, and so on. Now we can answer the question, what is a non-application layer protocol? Well, simply, a protocol at any other level. In other words, these are typically the underlying protocols of the application layer. For example, HTTP or HTTPS, SMB, and FTP are all application layer protocols implemented on top of raw TCP based on their RFC standard. Whereas ICMP is a non-application layer protocol that is most commonly used for ping. SOCKS is another good example of a non-application layer protocol. It exists at the session layer and will support other kinds of application layer traffic via its own protocol, typically used for proxying communications. First, we'll have a look at some real-world malware examples that use ICMP to communicate between infected hosts or with their C2 server. The first example is For Real, used by APT32, which FireEye has loosely connected to the Vietnamese government. For Real is one of APT32's backdoors used to establish a foothold in a target network. It then communicates back to its C2 servers using ICMP. The second example is TSCookie, which is malware used by a group called BlackTech. While TSCookie does support an application layer protocol like HTTP, it also uses a non-application layer protocol and ICMP to receive data which is configurable while the sample is running. ICMP isn't the only non-application layer protocol used though. China has been seen using session layer SOCKS protocols during their malware campaign. APT3 during their Operation Double Tap establishes a SOCKS5 connection to their C2 server. This is also combined with a custom protocol that sends integer commands that the malware will execute. These are all listed in the FireEye report, but things like Command 1 deletes files, Command 2 exits the malware, and Command 3 downloads content from a URL, etc. Also attributed to China, the bubble wrap malware also uses a SOCKS proxy for communication, in addition to some standard HTTP. Lastly, there are some samples that simply use raw TCP sockets and send information like we saw before from APT3. The Derusby malware only uses source ports between 31,800 and 31,900 and connects back to a destination port of 443, but the traffic is not SSL TLS encrypted. Based on analysis done by Fidelis Security, it is a 64-byte custom protocol beacon that includes a 4-byte XOR key to deobfuscate the payload. Lastly, the Crimson malware also uses a custom TCP protocol for communicating with the C2. Based on the figure in Proofpoint's write-up, it looks like it could also be raw data from the Crimson rat. Think like a reverse bash shell. So what can be done about these non-application layer protocols being used by malware? Unfortunately, the answer is not super exciting. We should eliminate the known bad traffic, or block traffic that is against policy. We should also allow known good traffic, HTTP or HTTPS to pre-approved sites, SSH to specific servers. or even SOX proxy usage to allowed proxies or by allowed users. Lastly, for everything else, there is active detection and prevention by a security team or a network operations center or using an IDS IPS product or service. This topic also remains a good candidate for machine learning and or artificial intelligence research applied to network traffic. So we've seen some examples from the real world, but maybe it's really only for sophisticated actors, and it really won't be very common in the boring, simple malware. Unfortunately, as I mentioned before, it's pretty easy to implement those custom protocols, and there's a demo coming up that shows you how to send data via ICMP in just a couple lines of Python. Before we wrap up this portion of the talk, I just want to reiterate those three main ideas. Malware can communicate using application and non-application layer protocols to send and receive information. It's not just theoretical and has been used by malware for many years, and this upcoming demo will show it's unfortunately pretty easy to do. We're going to start the ICMP demo now and show how easy it is to send data inside an ICMP packet, like you might have seen from malware samples using non-application layer communications. We're going to be using Python and Scapy in order to do this. Let's go ahead and create our ICMP file. Here we can see that we have the code needed for this short demo. We're going to import Scapy. We are then going to create a packet. The IP packet has a destination address of 127.0.0.1. Inside that IP packet we have an ICMP packet, and inside that ICMP packet we have data. Once we've created that packet, P, we're going to send the packet. So let's go ahead and save and quit this file and test to make sure it works. Since we're creating raw packets, we're going to need to open a raw socket, and that requires admin privileges. So we're going to be running this client demo with sudo. Looks like it worked. Let's go ahead and open up Wireshark so we can analyze it a little more. We're going to want to capture on the local loopback interface since we're sending the ICMP packet to 127.0.0.1. And we can just filter for ICMP traffic. Let's go ahead and send that packet again. We can see that packet pop up behind. Let's go ahead and minimize this window. We have our echo ping request, and inside the ICMP packet we have our data. And down in this byte disassembly, we can see our hello world information. So that's just a very simple proof of concept demo about how easy it is to send data in ICMP packets and why non-standard application layer communications are important to understand and analyze. I decided to include a bonus demo in this video. We're going to create raw TCP data as well to show the similarities between the raw ICMP and another useful example of how easy this kind of network communication using non-application layer protocols can be. So to start, we'll create our packet. We need to import Scapy. Now we'll create our TCP packet. We've created the structure of our packet, but we need to fill in some details, like the destination address and the ports. The important part of this TCP component of the packet is the D port and S port fields. These specify which source port and which destination port the TCP packet will be going to. Now we can send the packet, like before. Let's save and quit and test and see if this works. Once again, we're using raw sockets, so we need to use sudo It looks like it worked. Let's open up Wireshark to analyze it further. Once again, we'll be capturing on the loopback interface. Let's go ahead and filter based on information we already know. Now we can run our script. Again, we see our packet pop up behind. We can see that this is indeed from port 1 to port 1. We can see our raw TCP data that we put in the packet. And it is going to 127.0.0.1 from 127.0.0.1. So this is just another example of how easy it is to send raw data on non-application layer protocols using Scapy and Python. Hope you enjoyed the bonus demo.